Hey guys, here's the notes on means of frequency tables and weighted means. We're going to talk today about finding, or estimating actually, a mean from a frequency table, which as you know is divided into classes and doesn't have all the individual data points. So that is a drawback to a frequency table, is that you do lose the individual data points. However, they're very often used and are beneficial if the data set is large and overwhelming and you want to break it into a more manageable construct. And also, frequency tables or frequency distributions are a very nice way to organize data if you're going to produce a histogram. So let's get into the calculation here. First of all, a couple things we're going to need to add to the notes. They're missing a few things. First of all, there's a typo in step 3 here of the calculation. So it should say step 2. Find the sum of the products obtained in step 2. And then I've added a couple columns here that help organize those steps. So the third column that I added to the little table at the bottom is midpoints. So it's nice to find the midpoints and have them organized. So when we do step 2, multiply the midpoint of each class by the corresponding frequency. We have we're already set up to do that. And then the last column there is the actual products of midpoint times frequency. And I added a little totals. Let's make it totals at the bottom. I'll bring this line across. We're going to need a total for frequency, and we're going to need a total for this column here, midpoints times frequency. And you'll see why. I'll explain that further. And then I also added the directions here at the bottom, but you don't really need those if you want to just work from the 4-step calculation here listed at the top. You're welcome to add them, though. All right, so in a nutshell, if you think about the classes here on the left, let me just highlight these for you. These classes on the left are ranges. We don't know the exact value of any of these frequencies or data. These are the data values here. We don't know the exact value of any of them. We just know the class they fall. But we do have a certain number of data values. That is the sum of all these frequencies. Whoops. So when I add these up, I am getting a total of 74. It's not the color I want. 74 data values. That's what the sum of the frequency column tells us. So if we have 74 data points, we add them all up and divide by 74. That would give us the mean of our data set. Like I said, we don't know the exact value of those 74 data points, so we're going to estimate them. Now if we look at the first class, 0 to 4 years experience, what would be a good estimate of where these 10 people fall in the 0 to 4 range? Well, it would be the midpoint, the mean of 0 to 4. So the midpoint of 0 to 4 is 2. So we're going to simply call those 10 people. We're going to say they have 2 years of experience. So we have 10 people at 2 years. So you're imagining the data set is being built. We have 10 twos. In the 5 to 9 group, we're going to find the midpoint of that class, which is 7. So now we have 16 people that we're saying have 7 years of experience. So imagine 10 twos, and now we have 16 sevens. And we just work our way down the list. The midpoint of 10 to 14 is 12. 15 to 19 is 17. So we're just going to add 5 every time. 22, 27, 32, 37. Okay, so like I said, if you want, if we were finding the mean and we truly knew that we had 10 people with a 2, and we're now adding all of these values together to divide by the number of numbers, why bother doing 10 plus 2 plus itself 10 times? Let's just do 10 times 2. So that's why we do the frequency times the midpoints. 10 times 2 is 20. 7 times 16 is 112. 112. 21 times 12 is 210 plus 42. Is that 252? 12 times 17 is 204. 622s is 132. 527s is 135. 332s is 96, and 137, or 37, or 137 is what I'm trying to say. One teacher with, we're saying, is 37 years of experience. Okay, I will sum these values, and I'll be right back. Okay, I'm back. I got 988 for the sum of midpoints times frequencies. So again, finding the mean, we've essentially added the value of all the data points together, got a sum, and now we have to divide by the number of data points, which is 74. And our estimated mean is 13.35. I'm going to round that to 13.4. One value after the decimal, one place after the decimal, more than the data set itself, which is whole numbers. So 13.4 years is the estimated mean of this frequency distribution. And just let's go a step further and look at the table and see if that seems to be reasonable. We got the most values in the 10 to 14 class. The data is skew right, with more values trailing off toward the high end. Makes sense with a data set that starts at 0, because can't go any less than 0, but we can certainly get some higher values the farther we go away toward the greater side. It's close to 14, so it's close to the high end of that class, and that's probably those larger values drawing it toward a higher number, toward a higher value. So that seems to be reasonable. That probably would be what we would guess if we didn't do any calculations. So we like it. Okay, let's move on. This is the next page. Okay, a weighted mean is very similar to calculating, well, doing what we just did with the frequency table and estimating the mean. They're weighted because somebody makes a value judgment that some categories should be worth more than others. We do that here at the high school all the time. We give more weight to summative assessments than formative assessments. Another example would be college on the 4-point scale, which I mentioned we're going to look at. So we're going to learn how to calculate a college grade point average here. These are Jason Pitter's grade in a recent semester. Took some interesting courses there, as you can see. So I'm not sure how much you guys know about college grading, but this is how they do it. The letter grades, which most colleges use, are converted to numerical grades as such. 4.0 for an A, so in theory, if you got all A's, you have a 4.0. If you got all B's, no matter the weight, you have a 3.0. C 2.0, D 1.0, F, of course, 0.0. The other thing that makes a difference is the number of credits that each course is worth, something we also do here in high school. And those credits usually range from 1 to 4. You might have some courses with as many as 5 credits, but typically it's 1 to 4 credits. So there's going to be more weight on getting a higher grade in a course that's worth more credits, which makes sense. It does say here that colleges do convert ordinal data. They treat ordinal data as ratio data because we are going to find a mean, which really isn't appropriate, but nonetheless, that's what they do. Let's try one. And again, you're going to need some space here You're going to write in the space below here. So there's no steps on it, so we're going to have to just work it out ourselves. Let's give it a try. Okay, so here are the converted grades on the left. So these are converted from letter grades. So the 3.0 is a B, just as a reminder. The 4.0 is an A, another A, a C, and another B. Okay. You can see that the converted grades are being multiplied by the number of credits over here in the third column. And sometimes these are referred to as quality points. What we need is the sum of these quality points, much like we did with the frequency table and got the midpoints times the frequencies. We need to sum the quality points, or grade credits, and then divide by the number of credits. So let's get some totals. Number of credits, it looks like 15 credit semester, fairly typical. And the number of grade credits or quality points is 46. And 46 divided by 15 is a 3.06 repeating. We'll call that a 3.07. And that would be how you compute Jason Pitter's grade point average for this semester. And you could play around and see what change in his grades would have the greatest impact on his semester grade. Would getting one of those 4 credits up to an A have the highest impact? Would getting the 3 credit up to a B be more impactful, or maybe the 3 credit up to an A? But that's how you do it. Okay, the table on the last page here, the first one is irrelevant. Please cross that out. You don't need it. Oh, why isn't my writing moving along? Something changed. All right. Okay, I had to erase it. I don't know what happened there. But like I said, well, looks like I missed some. Like I said, you don't need that top table on the last page. And here is guided practice for you. Find Leah's overall grade in soccer science with those averages and those category weightings. Go get them.